In this video, we're going to talk about some more derivative rules. So we learned the power rule now, which is when you bring down the exponent in front of the x when you're taking a derivative. It's very rare you have a function that's just x with a power. There's some other things going on. So in this video, we're going to look at some rules that can help you kind of break down more complex functions. So here's the first rule. It says if you take the derivative of a constant, which is just a number all by itself, you're always going to get 0. And the reason for that is you could technically write this as x to the 0. All right, x to the 0 is just 1 because anything raised to the 0th power is 1. And then if I bring that 0 down, it doesn't matter what everything else is. There's still this 0 I'm multiplying by, and that's 0. And there's a few other ways, but this is just using our power rule, which we just learned. All right, you can see you get 0. All right, so if you ever take the derivative of a constant, you just get 0. All right, similar to how we could break down limits with pluses and minuses, we can do the same thing with derivatives. So if we want to find the derivative of these two things being added together, we can find the derivative of them separately, as long as we just keep the plus or minus between them. And if we find them separately, then we just kind of add the derivatives at the end. All right, so this helps us break down a kind of expression that has pluses and minuses and just a bunch of little problems. All right, one important thing is this only works with the plus and minus. It doesn't work with multiplication and division. We'll learn about that later. And the last one we'll learn for now is the constant multiple rule. So we saw the same thing with limits. If you're multiplying by just a constant number, like if you had like 2x or 5x squared, if you just have this number multiplying by your expression, you can just bring that out. You don't actually take the derivative of this constant multiple, and it just stays in front when you find the derivative. That's just the difference between just a constant all by itself. Without an x, that's always 0. But if you take the derivative of something being multiplied, that can just stay. All right, so here we're going to find f prime of x if f of x equals x cubed minus x squared plus 1. All right, so again, when we see these minuses and pluses, that just means we can do it as kind of 3 separate problems. So the first thing we do is we just take the derivative of x cubed. All right, using our power rule, that's going to be 3x squared. And then minus, and then next the x squared. The 2 comes down, we get 2x to the first. So again, you don't have to write the 1. And then the last one, the plus 1, that's a constant, it's a number all by itself, so we just leave it, that's plus 0. So I write it simpler. 3x squared minus 2x is the derivative of this function. All right, next one, f of x equals 2x to the 4th minus 3x squared plus 12x. All right, so a couple of things happening here. Again, we have the pluses and minuses, so we can break it down into just kind of 3 separate problems. And also we have these constant multiples. All right, they're being multiplied by something with an x, so they're not going to go away. Instead, they're actually just going to stay there. So what we're going to do is this 2 is just going to stay there. And then the derivative of x to the 4th is 4x cubed. All right, minus that 3 is just going to stay there. Derivative of x squared is 2x to the first. All right, plus that 12 is going to stay there. All right, what's the derivative of just x? X is x to the first, which means its derivative is we bring down the 1, subtract 1, x to the 0 is 1. So derivative of just x is 1. And now we can just simplify. This is 8x cubed minus 6x plus 12. All right, so you're just kind of separating these out into smaller pieces. All right, 3 individual pieces because of the plus or minus, and then we kind of separate out those constants that are being multiplied until the end. All right, so here's one for you to try and do, very similar to the last one. You're going to try to find the derivative of this function. All right, I'll show you the answer in 3, 2, 1. So the answer you get is 6x squared minus 12. And you might start to see a little pattern. Is that basically what you end up doing for these problems is you basically just end up multiplying this by that. You can kind of skip straight to the answer. So 3 times 2 is 6, and then I subtract 1. Here I can bring down the 6 times 2 is 12, and then I subtract 1 from the exponent. So that'll save you a little bit of time. You won't have to write this middle step. But that's what's happening is the constant multiple staying there, and then you're doing the derivative of the power rule, but you end up just multiplying those two numbers anyways. All right, so that you can just kind of skip this middle step once you get used to it. All right, so quick summary. You can break up derivatives into smaller pieces if there's addition or subtraction, but not multiplication. All right, there's a separate thing we'll have to talk about in a separate video. I have addition and subtraction is really nice. You just do it as a couple of separate problems. All right. And if there's a constant in front of an x, it can stay. If there's a constant all by itself, it turns into 0 when you do the derivative. All right, so make sure you just know the difference between a constant all by itself, like just 3, its derivative is 0, versus 3x, its derivative is going to be 3, because the 3 stays there, derivative of x is 1. All right, so that small thing is really important. All right, notice the difference in those.